we have to be particularly careful if our integral bounds include an vertical asymptote. So we should never integrate across these unbounded vertical asymptotes. Okay, because what will happen is if we don't recognize that we are integrating across an asymptote, you're going to get a result, but the result is invalid. So in this case here, when I graph this function, I get this function that looks like this, and my bounds are going to be from -2 to +2. Well, if I integrate across all the way from -2 to 2, I will integrate across a vertical asymptote, and my results are then invalid. So I have to be careful. So to do this, I have to set it up in this way. So I have to do this as a limit. So I'm going to have a limit from the left-hand side. Okay, so my limit as t approaches 0 for the integral -2 to t of 1 over the cube root of x dx. And then I need one from the other side. Plus, I'm sorry, we have to make sure that this is a one-sided limit because I'm approaching 0 from the negative side here. And then plus the limit as t approaches 0 from the other side, from the positive side. And this is going to be from t to +2 of 1 over the cube root of x dx. So because there is this vertical asymptote at 0, I have to make sure I apply a limit from both sides. And then I'm going to have to evaluate those two integrals separately from each other. And the results from those two separate integrals will give me a valid area result. So integrating this, I'm going to end up with anti-differentiating this. I get the limit as t approaches 0 from the negative side. That is power -1/3. So I'm going to increase the power to 2/3. So I get x to the power 2 over 3. I'm going to divide by 2/3. So I end up with 3 over 2. And then my bounds are going to be from -2 to t. And I'm just going to do this side first. So I'm going to plug in I'm going to put it into my definite integral form. So I end up with 3t to the 2/3 over 2 minus 3 times -2 to the 2/3 over 2. When I plug in 0 into here, I end up with 0 minus, and this is going to be positive, so that's going to be 3 over 2, and that's going to be the cube root of +4. Okay, so that's that first part, and then I'm going to do the second part. Really, the second part is really much the same. I'm going to end up with limit as t approaches 0 from the positive side, and this is going to be the antiderivative 3 over 2 x to the 2/3, and my bounds are going to be from t to 2. I'm going to plug in my actual limit values into the definite integral. So I'm going to end up with 3 over 2, and this becomes 2 to the 2/3 minus 3 over 2 times 0. I'm just going to make that 0. So I end up with 0 here. Okay, so then plus, this becomes 3 over 2 to the 2 squared, which is 4. And then I end up with the cube root of that. And we can see that that area is going to be 0 because they cancel out. So the area equals 0. Okay. Now, if I had integrated across this, our results are often invalid because of the fact that we're integrating across vertical asymptotes. So we have to make sure, first of all, identify when we have a vertical asymptote in our bounds, in between our bounds, and then split up that integral to two parts before we integrate.